Morning. Today we'll be talking about fields, and we're not talking about football field or any other type of field. We're talking about fields where forces actually take place. So straight to the point, what is a field? Now, a field is any area or space where a force is experienced. Now, this force could either be electrical, magnetic, gravitational, or any other. There are actually many kinds of force on earth. There's even forces, but we're dealing with science and we're dealing with um, specific kind of force. So, a line of force is an imaginary line shown showing the direction of action of a force in a particular field. Now, in a particular field, let me explain what that means. Now, the truth is that now, whatever force is taking place, right? It acts on a particular field, on a particular area. So scientifically, when they use some instruments to actually check, they will see that there are some lines that are indicating how the direction of how those forces are acting. There's something they call it line of force, so indicates how forces act in a particular field. Take for instance, when you place two magnets together, right? You know, when you have a magnet, you have the north and the south pole. So when the north pole and the north pole come together, they tend to repel, right? Like forces repel, and unlike forces they attract. The same way like poles repel and unlike poles attract. So if you use there are certain instruments that if you make use of those instruments and you look at those magnets, you will see some form of lines, so wave like lines indicating the how the force is acting. When you are dealing with magnets, you are talking about magnetic force. So just let's know that a line of force is an imaginary line showing the direction of action of a force in a particular field. Now, what makes up that field are two materials. Are you with me? There are two materials and a part and the force that is acting on that particular area. Now, if you have two, let me say, how will I explain it? Let's say you have two magnets, they are north and they are south pole. Now they are going to attract. Now the two magnets are the two materials, but there's also a force acting that will make them come together. So the force and the object now forms that field. So do we understand? So and I said remember, a field is an up in an area or region where a force is experienced. So how will I put it, the force, the two objects and what is trying to bring them together now forms that field. So a force is actually trying to bring them together. So that's why I said that force could either be electrical, it could be magnetical, if it could be magnetic, sorry, or it will be electromagnetic, it will be gravitational, whichever one you have. So and so on and so forth. So another lines of force, because you don't just see one line, you see lines. So the lines of force is now what indicates the direction of action of a force in a particular field. So there are basically four types of force, four types of field. I meant to say electric field, magnetic field, electromagnetic field, and gravitational field. Now, and I said, now to buttress the point. I said the type and number of charges associated with an electric field, as well as the arrangement of these charges, determines the pattern of the field. We talked about charges in our last class, so if you don't remember what a charge is, you can just back to that go back to that material or go back to the audio and try to know what a charge is. So I said let's use electric field as an example. Now, an electric field pattern is usually mapped out using lines of force. So a line of force is what it indicates movement. It indicates movement. The movement could be, most times you can have the movement circular, you can have them straight. So forces are acting, right? So when we are talking about an electric field, we are now talking about charges, positive and negative charge. Do we understand? That is why when positive comes in contact with negative, things tends to work out well, right? There tends to be a spark of, there tends to be electricity, if I may use that word. So So, and combination of these lines, you call them electric flux. So if you ask what is electric flux is the lines, is the number of lines of force. So that's just the idea. Now these are properties of lines of force. These are properties of lines of force. I will send this PowerPoint material as well, so you can as well look at it, read, adding to the knowledge you get from your textbook, and no more. So lines of force, they are imaginary. I said it, they are imaginary lines. They always make use of some scientific instruments to actually sit down. They said they repel one another sideways. I will explain that. Now they do not intersect. They are kind of parallel lines, and parallel lines are lines that never meet. Now they begin from positive charge and end on equal number of negative charge. I said they are straight, parallel, and uniformly spaced. Now they say they sometimes represent a non-uniform field. Yes. Now a non-uniform field now is a kind of field where a uniform field is actually when there's equal, how will I put it, equal force. The force is kind of equal on every side. But for this, and if you study the diagram, you will discover that the how will I explain it, the if you if you look at the diagrams of different types of field, electric field, gravitational field, magnetic field, you discover that at some point you discover that some lines are curved, some lines are straight. So it is not a uniform field. So straight. Now this is a diagram of an electric force around an isolated negative charge. Now scientists believe that there are charges everywhere, right? There are charges everywhere. So what this is trying to tell us is that this is an isolated charge. It's just on its own. It's not doing anything to anybody, but it is ready to receive into itself. That's why you see the line coming in. Do we understand? The line, this line now is like a line of force. It is ready to receive from whatever is close to it. Do you understand? From whatever is close to it. Now this is okay, there's supposed to be a diagram here for that of positive, but what you will now have here for that of positive is that you will have a plus here. You have a plus here instead of a minus now, and the direction of the arrow will now be facing up. Instead of coming inside, to be going out. That means it is ready to go and connect. It's just like the positive is like a man is going to look for his wife, while the negative is the wife waiting for the husband to come. So that's how it's supposed to be. Now these are two negative charges. Observe what they are doing. They are not even coming near each other. They are just going inside themselves. There's nothing to receive. This negative charge is not giving out anything. This negative charge is not giving out anything. So if they come together, there tends to be this repel. So that's why for your magnets, the positive and positive side, when they come together, they tend to repel. What it's trying to say is that, one thing about this field is that there is one part of that field. There are two sides to it. There's the positive and negative. For magnets, there's the north and the south. So the north is either going right. The lines are coming from the north to the south, or coming from the south to the north, whatever way it is. So these negative charges, they are like ready to receive. They are ready for charges that are coming. They are not ready. They are just like stingy set of people, like just there, right? So okay, these are two negative charge. So okay, there's supposed to be a diagram here. There's supposed to be a diagram here for that of positive, but the okay, that of positive, what we're supposed to have here is that the positive, you will have a minus and a plus. So that means the positive will be going out, while the negative will be coming in. You can consult your textbooks. It's all there, very clear. So I'm sorry for that. I'm really, really sorry for that mistake. There's supposed to be a diagram here showing the positive, but for that positive, what you will always have here is a plus, and the arrow will not be going inside, it will be going out. So when the arrow is going out, imagine this one, the arrow is going out, and this one, the arrow is going in. So that means this guy is going out to meet this one that is going in. Do you understand? What is trying to tell you that positive charges, they go out, they give off, while negative charges, they receive. So when the positive charges are giving off and the negative charges are ready to receive, they come together, and they kind of come together. So the first field we want to quickly consider. Okay, before I consider that, now what the heading you have here is electric force around two equal but opposite charges. What does that mean? There is a positive and there is a negative. So the positive will be giving off and the negative will be receiving. So there will be a kind of direction of movement from the positive to the negative. You can consult your essential physics or new school physics. It's there. It's clear. I'm really sorry for this diagram that is not here. I'm really sorry about that. Now let's quickly consider a particular type of field. Let's start with gravitational field. Now let's first of all tell ourselves what gravitation is. Now we know that everything that goes up must what? Come down. Everybody that grows tall must one day come down. Everybody that like the elders will say, anybody that leaves the planet, that comes out of the mother's womb, like comes to earth, will still one day go back to, we're made out of clay and will all return back to clay. So when an object goes up, it must come down because of a force called what? Gravity. So the earth is surrounded by a gravitational field. What is it trying to tell us? The earth is there. Whatever object you throw up, the earth exerts a force called gravity on that object, trying to pull it down. And one thing you should know is that the heavier an object is, the faster it is drawn to the ground. So if you drop somebody that is weighing 80 kg and somebody that is weighing 40 kg from an high-story building, the 80 kg person will get to the ground first. So that's why if you drop a pencil and a nylon, the pencil gets to the ground before the nylon. So, okay. Now, the law of universal gravitation. Now, this law was discovered by Isaac Newton. And the law, now, from the fact that every object that goes up comes down, he discovered a law. Right? He discovered a law. So the law states that every massive particle in the universe attracts every other massive particle with a force, which is, now the massive particle we are talking about here is the earth, attracts other objects that falls down. That the earth is on its own, and other objects, when they go up, the earth attracts it down, and it attracts it with a force. Now that force is gravitational force. Now, and the force is directly proportional to the product of the masses, of their masses. Now the mass of that object, and is inversely proportional to the square of their distance apart. That is distance between the earth and those objects, or distance between any two objects that has been talked about. So mathematically, this is what it means. F is directly proportional to m1 m2 over d squared. Now m1 m2 indicates object. I said F is the force of gravity between two objects. Proportionality sign, that is the sign. Then m1 is mass of object 1, m2 is mass of object 2, and d is distance separating the object, or distance apart. So quickly, what I want to also say is acceleration due to gravity, which is g. Now acceleration due to gravity is the force of attraction, is the force that attracts an object to the ground. Now this acceleration due to gravity, it varies. That is why the value is always either 9.8 in some places and 10 meter per second square. So our next class will consider other types of field as we go on. Thank you very much for your time.